In the diagram, we have B and D and C, which are in the horizontal plane. So these ones, they are horizontal, they are on the floor. And then we have a pole here, which is, they say, which is, AP is a vertical tower. And then we have an angle of depression, which is 30 here. Now, the angle of depression is such that it's an angle that we measure from the top to the bottom. Now, if you look at this line here, this is very important that we need to understand here. This line here and the horizontal plane, they are going to be always parallel to each other. They don't have to say it, they're always parallel to each other. So if these two are parallel to each other, they create a Z shape. If you look at this one and this one, they're going to create a Z shape. Meaning which if this one is state, automatical, this one here is also going to be actually to be there. So that's where we're going to start. We're going to start by telling them, Agri was just busy with the diagram, man. Which are adding things that we're going to need, some of the things that we might going to need so that we can solve this thing. So this one is state. When they ask me why am I saying that, I'm going to say alt angles here. Something that I'm going to need. Okay. Next, they say we have angle B. We have angle BDC, which is this angle here, is 90 minus beta. And then we also have this angle, which is 90 minus beta. So these two angles, they're equal.
Yes.
So if these two angles are equal, it makes this thing here to be an isosceles triangle because they are side opposite equal angles. And then they say, which this one here is H. So we have our height H. Okay, so now we want this thing here because we are also going to need it here. Now, in this triangle, because we already have two angles, it's like this one here, we can also get this one here. Even if they didn't ask us to get it, we can get it by saying, number one, we can say, which this thing here is 90 here. That's number one, in which we can do it. Another way, we can say this angle plus this angle plus this angle, they should give us 180, meaning this angle here, we can safely tell them which is 60 degrees. So what is the other angle that we can also get? We can also get this one here. Look at this one here. We can get it, this one. Now, what is going to be this angle here? It's going to be, let's call it angle B for now, but it can be angle B. Okay, it's DBC plus angle D. Yeah, angle D, we can call it angle D. Angle D plus angle C, they're supposed to give us 180. When they ask us why are we saying that, we know which is sum of angles of a triangle. Then it makes DBC to be equaling to 180 degrees minus, first one, it's going to be, okay, maybe let's do it this side first. Let's first add these things here because they are like terms here. So we have DBC, which is going to be given plus 90 minus a beta. And then we also have angle C, which is exactly the same thing, plus 90 minus beta. This is going to be 180. 90 and 90, they give us 180. This one and this one, they give us minus 2 beta. So DBC is going to be given by 180 degrees. This one, 180, this one. If we take it to this other side, it's going to become minus 180. Beta minus beta, I'm just saying beta and beta are going to give us minus 2 beta. When you take it to the other side, it says which are going to have plus 2 beta. Then 180 and 180 are going to cancel each other out. It says DBC is going to be equivalent to 2 beta. So we can come and update here and tell them with this one, we know it as 2 beta. Let us go and work then. What are they saying, these people here? They're saying we have determined the length of BC. Let's go and check BC. BC is this one here. They say we should tell them what is BC in terms of H. So it should have H on it. Now the good news is that if you identify this thing here, you'll see something here. This is a right angle triangle. It's something that we call a right angle triangle. And then with right angle triangle, you can use your trig ratios. I will take it out. So look at this thing here. This one here, it is a right angle triangle. It doesn't want to be taken out. Okay. So this thing here is going to give us the right angle triangle. And then from the right angle triangle, we want to get, we're looking for this side, which is BC. So we're looking for this one in terms of H. We're going to use this one. So the angle that we have is 30 here. The two sides that I'm talking about in relation to 30, let's check them. Which one are they? I agree this one is opposite 90. So this one is a hypotenuse side. It's fine. So we're done with the hypotenuse side. So what are we left with now? It can, this one here in relation to 30, what do you say this one is in relation to 30? This one. So this one is going to be adjacent to 30. Being specific, it's adjacent, not adjacent, adjacent to 30. This one in relation to 30, what is it? It's opposite 30. Everyone is happy. So we're looking for a trig ratio. We're looking for something that has opposite and adjacent. Which trig ratio seems to have both of them, opposite and adjacent, by the look of things? It's 10. Yeah, so if we take 10, we're going to tell them this thing here is going to be written as the tan of 13 is going to be equaling to opposite is H all over BC. And 30 is a special angle.
Yeah, it's a special angle.
Yeah. Is one?
1 over root 3.
1 over root 3.
Yes.
Okay, so we can tell them with this one here, it's, okay, let's write it here. So we have 1 all over root 3, which is going to be H all over 1 all over BC. Cross multiply. Cross multiply, this one goes there, this one goes there. And then it says with BC, it's going to be given as root 3 H, like this.
Yeah.
So we can come and update our diagram and tell them, this thing is simple. Now that we know this, let's update it. So I'm going to tell them with this one here, this side here, it's H root 3. This one here, it's H root 3. Or you can write it as root 3H, because I would know. People would ask, Marasa, why do you say now? It's H root 3. You can start with H or you can start with root 3. It doesn't matter. And then remember, we already told them which we know what is this one. We said this one here, it's 2 beta. Next, they say which we should write down DBC, which is this angle that we just spoke about. This one here. And then they say which we should write it in terms of beta. You can come in straight here and tell them which DBC is going to be equal to 2 beta. When they ask you why do you say that, you're going to tell them which is because it's sum of angles in a triangle. So you can just go to the straight to the answer.
Yes, sir.
Yeah. And then the next one, they say you should show us which DC. So we're looking for this side because every time you need to check which side are you looking for. So you're looking for this side here. So we need DC. And then they say which we should show them which DC is going to be root 12 plus H multiplied. It's root 12 multiplied by H multiplied by the sine of what? Of beta. Now, yeah, we can use the sine rule if we want. We can use the cos rule. Any one of them, we can use any one of them. But the simplest, usually, if it happens which you can use the sine. So I'm going to take this one and say these two goes together. If I want to use DC there, I'm going to tell them with DC all over. Why am I starting with DC? I'm sure DC, you see that. So for the fact that they want DC, I'm going to start with DC on top. And then DC all over the sine. What is the angle there? It's 2 beta. Then this is going to be equaling to. Now I can take any one of them because these two things are equal. So if I take this pair, let's take this pair. If I take that one, I started with the side. Even here I should start with the side. What is the side? The side is H root 3.
Yes.
All over
Sine
of 90 minus beta. We still fine. Now after that, let's use the general algebra that we know and see how far do we go. We don't know. If it doesn't work, we'll try the cos rule. It doesn't matter. I'm sure you've tried. The reason why I went with sine, because they can ask, why did you went with sine? It's because I saw sine here. And then I could have still went with cos, but I'm saying because I saw sine here, it made me to think of sine rule. So
It doesn't work.
yes,
It doesn't work.
It works.
this one of sine.
Yes.
It doesn't.
Okay, let's check it. It's fine. We'll see. It doesn't matter. If it didn't work, we'll check another one. So we have DC. DC, we make DC the subject. If we make DC the subject, we come here. This one is a double angle.
Yes.
So it can be written as, I'm
Yes.
going to start with this one because it's already there. So this
Yes.
one, it's H root 3 multiplied by 2. It's sine beta multiplied by cos beta. All over. This one, Coco rule.
Yes.
This is going to be the cos of beta. Now look at the cos beta then. Cos beta.
Cancel to start. Yes. I get it.
All right. And then here we are almost there. Because if you look at it, it has a root. This one also has a root. It's just with the root here is 12. No? It has an H.
Yes.
Yeah. It's H. It's H, right? And then the sine
Yes.
sine beta. Let's check,
Sine beta and sine beta.
check what do we get. So if you say
It's 2 root 3.
yeah, 12. If you say 12, if you say root 12, no? It should give you the same as 2 root 3.
Calculate 3 times 4.
I thought it's wrong.
And the other thing that you could have done here, reverse psychology, you could have said root 4. Actually, if you have root 4,
Yes.
if you have root 4, you can say we multiply whatever is inside the root. So its root is root. I mean, you say 3 multiplied
Yes.
by 4, and then it's going to give you.
So,
Mr.
Mr.
Yes.
I have a question.
Yeah, we'll.
I am asking first.
12
Mr.
multiplied by the sine.
Mr. I didn't want to leave it as 2 root 3 because the
No, we didn't leave it as 2
Yeah.
root 3. We leave it exactly the way they want
Oh,
it. But yes.
Let them I got root 4 in again.
Mm.
He got 2 root 3 is equal to root 12. The 2 root 3 is equal to root 12.
Let me give
Am I
it
fine?
to you.
Is it fine?
You said what?
I get to know. I said 2 root 3 is equal to
2
root.
So when you told them, you
Yes.
assumed.
I'm not
No,
assuming. It's
like
true.
this.
This is mathematical.
Yeah,
like
but
this.
okay. Yeah, it's fine because they're not even going to give us a mark for changing, which we changed this one to be root 4. But what we needed to know is that we can change this. If we're using last year, grade 11, grade 11, we're dealing with sets. When you were given, let's say you are given root 6, they will say, how would you simplify root 6? Or they will say, okay, let's take something like, root 6. You can say which wanted 8. Yeah, with 8, you can say this thing here can be written as root 4 multiplied by 2. And then you say this is a square root, then this is 2 root 2. So that one comes, and then if we're able to go there, we should be able to go back there.
Yes, fine.
Mm.